Hello, and welcome to the Century College Digital Fabrication Laboratory. We've been working with the Fab Lab community for about the last 10 years, since about 2006, 2007. This is the third facility that we've moved into. It's probably the nicest. We started in a small room, almost a closet, moved into an old classroom, and we built this and moved into this about a year ago. It's about 8,500 square feet. You don't need this much space. However, we've evolved this into a couple different program areas, and I'll talk a little bit about those. So I'm going to give you a tour of the lab. I'll talk about how our lab has evolved, both from a technology and from a degree program perspective, and some of the things that it can do. But first of all, I want to talk a little bit about Fab Labs as an incubator for STEM. So the Century College Fab Lab was initiated as a tool to help extend our engagement in our technical programs with a focus on science, technology, engineering, art, and mathematics. And we have students from all those programs at Century College who utilize our Fab Lab in some way. We're connected with the Fab Global Network. Today there's well over 1,000 Fab Labs in the network. We were the 23rd Fab Lab in the world, and now I think, like I said, there's over 1,000 Fab Labs. The Century College Fab Lab, we also kind of talk about it being a high-tech tinker's workshop. So in this particular space, we have off-the-shelf industrial machines, anywhere from computer systems running CAD program to CNC machines. We just launched a Center for 3D Printing a number of years ago. And as a part of our involvement with Fab Labs, we've used the Fab Lab to help launch a new degree program at Century College, a new two-year AAS degree called Additive and Digital Manufacturing, where the emphasis of this new program is to prepare students to work in the manufacturing industry, where they utilize more and more digital technologies, not just 3D printing, but CAD systems, CAM systems, automation and control. And there's also a pretty heavy emphasis into the Internet of Things that we'll probably talk about a little bit later. We also have our Fab Lab linked to our engineering program. So we have a degree in engineering, which is transferable to other four-year colleges in the region. So our students have an engineering framework here. They have an additive and digital manufacturing, and it's really a place where we apply science. So the Fab Lab is an integrated type of environment. It's just not for engineering, but it's for multiple areas. Well, come on in, and we'll walk around the Fab Lab a little bit and take you on a tour. So Fab Labs are maker spaces. I also like to point out that we've been involved with the Massachusetts Institute of Technology, or the MIT. Fab Labs were really kind of incubated at the Center for Bits and Atoms under Dr. Neil Gershenfeld. We're lucky enough to have been affiliated with this network, like I said, since about 2006, 2007. And we still very much enjoy having a partnership. And that's, if you're a Fab Lab, you're really part of this larger global network of makers. But a big part of this is where the research is conducted, and then we're kind of following with what's happening at MIT. So very exciting times in this digital field. So this is our Center for 3D Printing. We launched this center about 3 years ago because of all the development that's happening in the additive manufacturing world, or the 3D printing world. We started off with powder-based, the Z-Corp 3D printer, and I think we're up to 8 3D printers right now, and we're looking at purchasing some newer ones. Our Center for 3D Printing is also utilized by our orthotics and prosthetics program, and we're starting to branch out in some of the applications for the Fab Lab into other degree programs at Century. We also do a fair amount of work with the outside community. So following the charter of Fab Labs, being a Fab Lab affiliated with the network, we're open to the community, or open to the public, and they come in here and invent things and work on ideas and prototype things, and oftentimes they work with our students. So we started our Center for 3D Printing, and like I said, a number of years ago when we saw the growth in 3D printing, and currently our evolution into what we call Fab Lab 2.0 is we're using our Fab Lab to build machines. So in the past, the Fab Lab had an orientation to make various types of components. All of these are various types of products that were made in the Fab Lab using CAD, some kind of a computer software, and then we either 3D printed them, or we cut them on the laser, or we did some type of processing. So this represents a collection of different things that were built in our labs, and now we're trying to evolve our lab into what we call Fab Lab 2.0, where we're using the Fab Lab to make a Fab Labs. And so in a couple of weeks I've got 6 students building their own 3D printers as part of a course called How to Make Almost Anything, which we modeled after MIT. So come on over and I'll show you what's in some of those printers. So here's an example of a part that our students are building. This is a part that actually has movement. It's like an alligator, and you'll see the CAD file. This part is being printed right now, and if we look inside of this desktop printer, we can actually see the material being laid down. And here's an example of a part that was printed earlier today, and these are some things that some of the art students were making that come over and use our Fab Lab. So the uniqueness about a 3D printer is that it's an additive process, where instead of cutting away or removing material as you would in a conventional manufacturing, this is a newer methodology where the materials are built up. This is a little figure that we built. The black material or the darker material is a support material that will be washed away once we put it into a tank, and we're left with something that looks like this. These weren't individual parts that were assembled. This was all printed as one component with the support material as part of the build process, and then we wash this away and we end up with something that has interchangeable parts. So we're fortunate enough in the Century College Fab Lab that we have what I'm going to refer to as some industrial scale 3D printers. And these are all parts that we printed yesterday and today. And these are going to be the corners for some 3D printers that we're going to build as a part of a class project. You'll be able to see that 3D printer near the end of this video once we get those all assembled. So remarkable machines, and the aspect of having a 3D printer not only enables us to reach, I suppose, into the future a little bit more, but to really have that CAD-CAM orientation and really help prepare students for the types of organizations that they're going to evolve in the future. So whether they're going to work for a medical supply company or medical device company or other industrial companies that make and fabricate things, the future is about more and more technologies being introduced into what we like to call the additive market. So this has been a big part of where we've been going with the Century College 2.0 Fab Lab. Another set of technologies that we utilize a great deal in the Fab Lab are laser cutters. Probably the most used piece of equipment in the lab, which is why we have 2 of them. We started with a smaller 45-watt laser, which prints a 18 by 24 surface, and we bought a larger form factor, a 110 or a 120 laser, which enables us to put a 2 by 3 foot sheet in. So we utilize this for prototyping. We cut a lot of cardboard to test your ideas, to make sure everything is done, and once we get everything all prototyped, then we'll go to an actual scale model. Here's an acrylic object that was built in the laser cutter. We also use it for prototyping different materials, as well as making some relatively useful projects. So here's one that's a wine carrier or a bottle opener that has what we like to refer to as a living hinge, and this was cut using the laser printer as well. So it's a very useful set of machinery. You can do some very intricate or some delicate cuts. Here's an object that was printed by some of our students a couple years ago, and this entire this entire case was cut with the laser, and you can see the detail that we were able to do it. So it's a machine, again, it uses a digital file, but lasers are a big part of a Fab Lab. Another very useful piece of equipment that we typically have in Fab Labs is a Modella mill. It's a smaller unit. What we use this one for is to make our own electronic circuits. So rather than breadboarding these, we'll actually design these with a software program, and we'll create the circuitry. We'll use surface-mounted technology, and this happens to be an interface. Basically, it's a thin client computer that was made a couple years ago. A very important part of our Fab Lab is the electronics workbench, or the electronics area. We use this as we're getting more and more into the Internet of Things. Students build and design their own electronic circuits as part of various systems that they're going to manufacture. So we use the Modella as a part of our electronics build station in Fab Labs. So the third piece of equipment that you'll find in the Fab Lab is a roll-in vinyl cutter. And we use the vinyl cutter to do all kinds of signage and all kinds of stickers. We also use it to cut, to make our own electronic circuits. So a lot of the Fab Labs will use the roll-in mill to mill out this. You can also get a copper foil, and you can cut electronic circuits and use surface mounted technology. We do some of that here. We primarily use our mill for our electronics, but we do this one to make all kinds of signs and to decorate, if you will, a lot of different. So a very handy piece of equipment, relatively inexpensive. So this area of our Fab Lab is where the students can come and work and do their CAD work. So we've got about 20 computer stations in here. A lot of our students have their own laptops with the CAD programs, whether it's SolidWorks or Inventor or Pro-E. But this is an area that we've designed, so it's an interactive area. Students can collaboratively work on projects, and we try to incorporate collaboration areas within the Fab Lab. So much of what we do is a collaborative and a collaborative framework, and not necessarily just an individual. But this is an area where students can work and do their design work. So we don't have to take up time in the machines. You do your design work over here, and then we ship the files across our network to the pieces of equipment. So this is another area that we have housed inside of the Fab Lab, our electronics area. Like I said, there's so much going on with the evolution of the Internet of Things. Works very, very nicely. It's used primarily by our students in our engineering program. So also another important part of the Fab Lab is we designed a conference room. We have a lot of meetings with outside groups, as well as students have this opportunity to come and close the door and have what I like to call a professional conference room. So we've designed this as a collaboration space. We do a lot in Fab Labs with invention and innovation, and just a place to meet and have discussions on a variety of topics. This is an example. My additive and digital manufacturing 3D class is currently in the process of building some open source 3D printers. And so we do a lot of planning, and you'll see some documentation on the walls. Nice thing about this lab is you can write on all the walls. So it works just excellent as a meeting space and a collaboration and an innovation space. So it's a great community space. Another very important part of the Fab Lab is our CNC machine. We use ShopBots. We have the ShopBot Buddy, a 4x4 ShopBot. We also have a 4x8 ShopBot, and we have what's called a HandyBot. So we utilize this an awful lot. This is our CNC lab, so we've tried to design a space where students use conventional tools, drill press, sanders, chop saw, for some Festool equipment. And so here's a long board that a student is cutting, and we just finished this the other day using this particular machine. So whether we're cutting wood or metal, this is a very useful piece of equipment in the lab. Students in my morning How to Make Almost Anything class, I have two students, and they're both making stitch and glue kayaks. So one of the more recent additions to the Fab Lab has been the Festool product line. We really like this setup. So this really replaces a table saw, and we can cut almost any angle in here. It's got an indexing system, a very handy piece of equipment that we find extremely helpful for cutting stock to size, but also is doing some other intricate cut. So within this CNC room, we've got some conventional equipment as well as some digital equipment. So this is a heavily used part of our fab. Another very important part of Fab Labs is our video conferencing capabilities. All the Fab Labs connected around the world have some form of video conferencing capabilities. We conduct meetings, we have conferences, we teach classes through the global network, through what's referred to as the Fab Academy. This is a very important piece of technology. This enables our students to work collaboratively regardless of locations. I have students that have worked with other students in Iceland. We've talked to the people in the Fab Lab Norway, as well as the people at MIT and other places around the world. So video conferencing is a big part of the Fab Lab set of technologies, and they're utilized a great deal. So our Fab Lab has attracted students from not only around the region, but from across the United States. We have some students that have found our additive and digital manufacturing program. So we have students here from other states in the U.S., as well as we've attracted some students globally. This is Abukari Adam, we call him Abu, who just graduated from the engineering program a year ago. He came here from the Ghana Fab Lab. Was one of our favorite people, and last year he was awarded the Engineering Student of the Year. So Fab Labs are very interesting environments. They're really ecosystems. There's a lot to do in a Fab Lab. They're really, like we said before, STEM, tinkers, workshops, a lot of technology, a lot of integration, but the important thing is that Fab Labs excite students. They get students excited about engineering and technology and math and the whole set of opportunities that are evolving in today's business and industries. And as our students are building machines, they're actually building systems. So as they incorporate the Internet of Things and 3D printers, and as we do more and more with robotics and automation, it's important that our students understand a wide variety of tools, not just the digital tools, but some of the analog tools as well. And we'd invite you to come by and see us. If you're a community member and you want to get involved with the Fab Lab, whether you're a volunteer or you would like to take our How to Make Almost Anything class, a lot of different ways to get involved with the Fab Labs, both at a local level as well as a state, regional, and global level. So thanks for visiting, and we hope to see you in the future.